Art Zencraft measures 125 volts per meter electric field between some parallel plates separated by 3.1 millimeters. So that's 3.1 times 10 to the minus third meters. What must be the voltage across them? So literally, here are these parallel plates, and we've attached this to some power supply, some voltage source, whoops, like this. So the top of this is positive, right? That's a cell. This is the positive side. There's a negative side. And this is 3.1 millimeters, right? So let's see. Hold on. Electric field is the opposite. Again, I'm going to ignore the minus sign on this. Okay, so let's see. This is 125 is equal to, we don't know the change in voltage, right? I'll keep that minus sign there. I'm still ignoring it, though. And then my change in R is 3.1 times 10 to the minus third. So basically, if it's 125 volts per meter, then this isn't even a meter, right? Okay, so let's see. 125 times 3.1 E minus 3. It's a fraction of that. I'm getting that the change in potential is 0.3875 in magnitude, right? Now, which way it actually is, you'll have to determine from a drawing or something like that, right? That's the absolute value of it.